Your CFO just asked a question nobody on your team can answer. What exactly are we paying for? Not a trick question, a real one. 18 months into your Copilot deployment, the promise was 2 to 5 hours saved per week per user. The invoice says something different. And somewhere between the pilot presentation and the quarterly budget review, 3 hidden cost layers appeared that nobody warned you about. By the end of this episode, you'll have a framework to audit every dollar your organization is spending on AI, and a clear picture of where that money is actually going. The entry fee nobody reads carefully. Let's start with the number everyone knows, $30 per user per month. It sounds simple. It isn't. That $30 is an add-on. It sits on top of whatever your organization already pays for Microsoft 365. And if you're a mid to large enterprise, that base is almost certainly E3 or E5. E3 runs roughly $36 per user per month. E5 runs around $57. So before a single Copilot prompt gets typed, you're already at $66 to $87 per user per month just to reach the starting line. And the starting line keeps moving. As of July 1st, 2026, Microsoft has implemented list price increases of 9 to 33% across most business and enterprise plans. Business Basic went from $6 to $7.50. The Frontline F1 license went from $2.25 to $3. That's a 33% increase for your lowest cost users. E3 and E5 are up roughly 9 to 10%, and these aren't negotiable the way they used to be because Microsoft eliminated enterprise agreement volume discounts in November 2025. Every customer now pays level A list price regardless of how many seats they buy. The leverage that large enterprises used to have in renewal negotiations is gone. Now Microsoft has introduced the E7 Frontier Suite at $99 per user per month. It bundles E5 M365 Copilot, the Entra Suite, and Agent 365 into a single SKU, marketed as roughly 15% cheaper than buying each component separately. And that's probably accurate. But here's what the math doesn't show. You're now committing to a single vendor for identity, security, productivity, and AI in one multi-year contract. That's not a discount, that's a dependency. Analysts watching Microsoft's commercial strategy since 2023 have summarized it in one phrase: charging more and giving less flexibility. The elimination of tiered volume pricing, the bundling of AI into high-cost suites, the removal of standalone Copilot Pro for consumers, these aren't isolated decisions. They're a coherent commercial strategy to normalize AI spend as a fixed, rising cost of doing business. For finance teams, the shock comes at renewal. Organizations are seeing 40 to 50% effective price increases when they account for both the list price hikes and the loss of historical discount structures. A company that was paying $45 per user per month 2 years ago can now be looking at $65 to $75 before Copilot even enters the conversation. Here's the critical point. None of this is the Copilot tax. This is just admission. The base license, the E5 stack, the Frontier Suite commitment, this is what you pay to get into the building. The tax is what happens once you're inside, when the billing model shifts from predictable seats to something far less visible. The seat cost is on your invoice. What comes next isn't. 2 billing systems running simultaneously. So you've accepted the entry fee. You know what the seats cost. And now you think you know what AI costs your organization. You don't, because Microsoft doesn't run one billing system for AI. It runs 2, and they operate on completely different logic. The first is licensing-based. This is the world most finance teams understand. You assign a seat, you pay a fixed monthly rate, you forecast it by multiplying headcount by price. M365 Copilot falls here. So does GitHub Copilot. So does Teams Premium. Predictable, structured, easy to model. The number on the invoice matches the number in the spreadsheet. The second system is consumption-based. This is where Azure OpenAI tokens live, where Copilot credits get billed, where security compute units get consumed. Nothing here is fixed. Everything scales with usage, with how many prompts get fired, how long the context windows are, how many agent loops complete before a task resolves. The billing is variable, the visibility is low, and the reconciliation is manual. Now here's where it gets complicated. Some of Microsoft's products don't fit cleanly into either system. Copilot Studio, for example, hits both at once. You pay a per-user license to access the platform. Then the agents you build on that platform consume Copilot credits every time they run. And those credits appear not in your M365 admin center, but on your Azure bill. 2 separate invoices, 2 separate approval chains, 1 product. The same logic applies to Security Copilot, which Microsoft bundled into M365 E5 in January 2026 with a monthly security compute unit allocation. Use more than your allocation and you spill into variable as your consumption. A security analyst running a complex threat investigation can exhaust a month's SCU budget in a single afternoon of intensive queries, and that overage shows up somewhere other than where your IT team is looking. This fragmentation has a practical consequence that most organizations don't fully appreciate until they're sitting in a budget review trying to explain a spike. There is no unified AI consumption dashboard. Finance teams reconciling what AI actually cost last quarter have to pull reports from at least 3 separate places. the M365 Admin Center for seat-level licensing, the Azure Cost Management Console for token and compute consumption, and Copilot Studio's analytics for agent-level activity. These reports don't automatically align. The data formats differ, the attribution logic differs, and the billing cycles can differ. One user interaction can trigger all three simultaneously. A knowledge worker asks Copilot to summarize a document and draft a response. That request touches the M365 Copilot license. If the response pulls from a custom agent built in Copilot Studio, it consumes credits. If the underlying model call routes through a custom Azure OpenAI deployment, it burns tokens billed directly to Azure. The user sees one interaction. The CFO sees three cost lines on three separate invoices. This isn't an accident of product design. It's a consequence of Microsoft building AI capabilities across an ecosystem that predates the AI era, then layering new consumption models on top of legacy licensing structures. The architecture reflects how these products were acquired and integrated, not how a coherent billing system would be designed from scratch. The practical result is straightforward. Most organizations believe they know what AI costs them. They know the seat count, they know the per-user rate. What they're missing is everything underneath. The variable consumption layer that runs in parallel, charges differently, and reports separately. That's the layer where the real money disappears. What a token actually costs you. To understand where the money goes, you first need to understand the unit of consumption. And for AI, that unit is a token. A token is roughly 3 to 4 characters of English text. Not a word, not a sentence, a fragment. The word enterprise is about 2 tokens. A full paragraph is somewhere between 75 and 150 tokens, depending on word length and punctuation. A standard page of business text, around 750 words, runs approximately 1,000 tokens. A dense technical document with longer words, code snippets, or specialized terminology can push 300 to 500 tokens per page. This matters because every Copilot interaction has 2 token components, what goes in and what comes out. Input tokens carry the prompt, the context, any documents you've attached, any previous conversation history in the session. Output tokens are the response the model generates, and they're priced differently. On Azure OpenAI, where token pricing is actually visible to customers, GPT-5 runs 1.25 per million input tokens and $10 per million output tokens. That's an 8x price differential between reading and writing. Output tokens aren't just more expensive, they're often where the waste concentrates because a vague prompt generates a long, verbose response. More on that shortly. Now, M365 Copilot doesn't expose this math to you. The $30 monthly fee abstracts all of it into a flat rate, and Microsoft manages the underlying token economics internally. But those economics are real, and they determine how Microsoft makes decisions about model selection, feature rollout, and the caps built into different license tiers. The abstraction benefits Microsoft's simplicity narrative. It doesn't necessarily benefit yours. Here's why the hidden economics matter for your organization specifically. A light knowledge worker, someone using Copilot occasionally, maybe summarizing a few emails, running a quick document search, generating a short status update, consumes somewhere between 40,000 and 100,000 tokens per month. That's the low end of the usage curve. A heavy analytical user, a consultant building decks from research, a lawyer reviewing contracts, a financial analyst running iterative Excel queries with complex context, can reach 1.6 million tokens per month. That's a 16x to 40x usage gap between the lightest and heaviest users. And under flat per-user licensing, they both pay exactly $30. What this creates is a structural cross-subsidy. Your light users subsidize your heavy users. Microsoft prices the flat license around an assumed average distribution of usage across the organization. If your workforce skews heavily toward light users, which is true for most organizations deploying Copilot broadly, you're paying frontier model prices for workloads that don't justify frontier model economics. You're covering the cost of summarizing one email thread per day with pricing designed for someone processing hundreds of pages of legal discovery. The inverse problem also exists. If your organization has a small concentration of extremely heavy users, developers running agentic workflows, analysts processing large document sets, researchers doing intensive retrieval, those users may be generating token volumes that cost Microsoft far more to serve than the $30 license covers. Which is one reason Microsoft is moving consumption-heavy products like GitHub Copilot and Copilot Studio toward explicit metered billing. The flat license isn't permanent, it's a transitional model on the way to a consumption-first architecture. Security Copilot already uses security compute units. GitHub Copilot switched to AI credits in June 2026. The pattern is clear. As Microsoft's internal token costs become more variable with frontier model usage, they push that variability toward the customer through metered tiers. So even if you're currently paying a flat fee and token costs feel invisible, what you're seeing now is the pricing model before full transparency, not after it. The tokens are already there. The bill just hasn't fully arrived yet. The idle token problem. Knowing what tokens cost is one problem. Knowing how many you're wasting is a different one entirely. The term idle token waste doesn't appear on any invoice. It's not a line item Microsoft surfaces to admins, and there's no dashboard that calculates it for you. But it's real, it's measurable in aggregate, and it's almost certainly one of the largest controllable cost variables in your AI deployment. Idle token waste is tokens that get billed but don't contribute meaningful value to any output the user actually sees or uses. 4 categories drive most of it. The first is background completions that never reach the screen. The model generates a suggestion, the user switches tabs, closes the window, or types over it before it renders. The inference already ran, the tokens are already spent. The second is suggestions that display but get discarded immediately. The Copilot autocomplete that appears, gets read in half a second, and gets rejected with a backspace. Generation cost is identical whether the suggestion takes 10 seconds to read or 0. The third is unnecessary context overhead. Large persistent instruction blocks, system prompts injected on every single request, entire repository indexes that get scanned even when the task only touches 2 files. This context accumulates quietly in the background of every interaction and charges at the full input token rate every time. The fourth, and the most expensive, is agentic chatter. Agent workflows that loop through planning, calling, evaluating, and replanning without converging on a better result. Each loop is a full token event. A poorly designed agent that runs 6 planning cycles when 2 would suffice doesn't just cost more. It costs 3 times more and it produces the same output. GitHub gave us a rare concrete look at this when it started publishing internal token consumption reports for Copilot-powered workflows. A report from March 2, 2026 showed 104.5 million tokens consumed in a single day across 75 workflow runs covering 41 distinct workflows. One workflow alone, a CI failure doctor agent, consumed 28.1 million tokens across just 13 runs. That's 2.2 million tokens per run for a diagnostic task. What makes that number instructive isn't the scale. It's what happened next. That same reporting period showed usage 37% lower than the prior measurement window and 56% lower than the all-time peak of 237.8 million tokens recorded on February 11, 2026. The work being done hadn't meaningfully decreased. The workflows had simply been tuned. No teams were laid off. No features were removed. Engineers reviewed the agent chains, trimmed unnecessary loops, tightened context injection, and improved routing logic. More than half the token consumption evaporated. The closest published analogy for Enterprise Copilot comes from Anthropic's developer tooling ecosystem. Claude Code, a code assistant with usage patterns similar to Copilot's agentic features, typically runs $150 to $250 per developer per month before any optimization work is applied, roughly $13 per active day. After systematic optimization using documented practices, model routing, context management, session discipline, tool pruning, teams report 40 to 85% reductions in total token consumption. That isn't a marginal efficiency improvement. That's a fundamental restructuring of what the system actually needs to do versus what it was defaulting to do. For Enterprise Copilot, there are no formal published benchmarks yet on idle waste rates. The token-based billing model is too new, and the telemetry most organizations have access to doesn't separate productive from wasted tokens at a granular level. But working from the GitHub workflow data, the Claude Code optimization evidence, and the cloud infrastructure waste patterns that FinOps teams have tracked for years, a reasonable working hypothesis puts unoptimized enterprise idle token waste somewhere between 30 and 60% of total billed tokens. That means somewhere between a third and more than half of what you're paying for AI computation right now isn't producing value anyone can point to. The billing infrastructure to make this visible is arriving. GitHub's switch to AI credits on June 1st, 2026 means every unproductive token is now a direct cost line, not an abstraction. Other Copilot surfaces are moving in the same direction. Idle waste is a structural problem with a structural fix. But there's a behavioral problem sitting on top of it that makes the structural problem worse. The lazy prompting tax. The idle token problem is structural. It lives in the architecture of how agents loop, how context gets injected, how background processes fire. You can fix it with engineering. What's harder to fix is what happens at the keyboard. Most users interact with Copilot the way they learn to interact with Google. Broad query, scan the results, refine, repeat, type something vague, see what comes back, add a follow-up, narrow it down. This worked fine for search because the cost of a bad search query is 0. The cost of a bad prompt is not 0. Every clarification turn in a Copilot conversation is a token event. The first message goes in as input. The response comes back as output. The follow-up message goes in carrying the full prior conversation as context. The next response comes back, longer now because the model is synthesizing more history. A 5-turn conversation to arrive at one usable paragraph can consume 10 times the tokens that a single well-structured prompt would have required. Same end result, 10 times the compute. Under flat licensing, this was invisible. The meter wasn't running. Under consumption billing, every one of those turns has a price. The context window problem compounds this. When users aren't sure what information the model needs, the natural instinct is to give it everything. Paste in the entire contract, attach the full email chain going back 6 months, drop the whole code base into the prompt and ask why one function is behaving unexpectedly. This feels thorough, it's actually expensive. Input tokens are the cheaper side of the pricing equation, but context window abuse drives them to scale in ways that quickly overwhelm any savings from using a cheaper model. And then the output arrives. Because the model received a large, unstructured input, it generates a long, comprehensive response that addresses every dimension of what you gave it, including all the dimensions you didn't actually need. Output tokens cost 3 to 10 times more than input tokens depending on the model. The verbose response to the vague prompt is the single most expensive interaction pattern in any AI deployment. Reasoning models make this worse. When a model runs extended chain of thought processing, working through a problem step by step before producing a final answer, it generates what are called thinking tokens. These are internal reasoning steps that consume compute but don't appear in the visible response. On some reasoning model configurations, effective cost per interaction can run 3 to 9 times higher than the headline per token rate because of these hidden reasoning steps. A prompt that looks like it should cost a few cents can cost 30 to 90 cents when a reasoning model spins up a full deliberation chain for what was essentially a simple task. None of this is a user failure. Users weren't trained on prompt economics because under the legacy flat licensing model, prompt economics didn't exist for them. There was no feedback loop, no signal that a poorly structured prompt cost more than a well-structured one. The behavior developed in an environment where tokens were free, and it persisted into an environment where they aren't. This is the core of the lazy prompting tax. It's not that users are careless. It's that the system never taught them that carelessness had a cost. Every vague prompt, every unnecessary attachment, every 6-turn clarification loop that could have been one well-scoped request, none of that registered as waste under the old model. So the behavior is a governance failure wearing a user behavior disguise. The organization deployed a consumption-sensitive tool without building consumption awareness into the deployment. No prompt guidelines, no context discipline policies, no training on when to use a reasoning model versus a standard one, or when to reset a session that's accumulated irrelevant history. The prompting problem is fixable, but fixing it sits on a foundation that's already unstable, because the outputs users are trying to verify aren't always correct. The verification tax. Layer the hallucination problem on top of everything we've just covered, and the cost picture gets significantly darker. Here's what the verification tax actually is. The extra human time required to check, correct, and document AI-generated work before it meets professional standards, not the time to generate the output. The time spent after the output arrives by someone qualified enough to know when it's wrong, and it is wrong with surprising frequency. Research benchmarking LLM accuracy on open-ended knowledge-heavy tasks puts hallucination rates between 50 and 82% depending on model, domain, and task structure, not edge cases, not unusual prompts. Routine professional tasks in areas like tax research, compliance review, legal analysis, and client-facing documentation. The model produces fluent, confident prose that reads like it was written by someone who knows what they're talking about. The problem is it sometimes wasn't. The model pattern matched to what a correct answer looks like without actually being correct. This creates a verification burden that doesn't disappear because the AI got faster at drafting. A tax professional reviewing an AI-generated analysis of a multi-jurisdiction filing still has to read every line. A compliance officer reviewing an AI-drafted policy still has to verify every citation. A lawyer reviewing an AI-produced contract summary still has to check every clause reference against the source document. The AI may have cut the drafting time from 2 hours to 15 minutes. The review time didn't shrink proportionally because the reviewer has no way to know in advance which parts of the output are correct and which aren't. They have to check all of it. Practitioner analysis of verification costs in regulated workflows puts the overhead at up to 48% above baseline in judgment-heavy processes. Meaning, if the underlying task without AI takes 10 hours, a workflow that uses AI for drafting but requires professional verification can take up to 14.8 hours total. The AI saves time on generation. The verification absorbs a significant portion of those savings, and in some cases, all of them. The math gets uncomfortable when you apply fully loaded labor costs to professional review time. At $80 to $200 per hour for a senior knowledge worker, the person qualified to catch what the AI got wrong, 2 minutes of review per AI answer costs between 2x67 and 6x67. 10 minutes costs between $13 and $33. Scale that across a day of AI-assisted work in a regulated environment, across a team, across a quarter, and the free AI draft has a very real cost attached to it. It just doesn't appear on your Azure bill. There's a compounding problem here that the token economics make worse. Per token pricing doesn't discriminate between right answers and wrong ones. A hallucinated response costs the same as a correct one. A long hallucinated reasoning chain, where the model doubles down on an incorrect path and elaborates at length, costs more than a short correct answer because it generates more output tokens. You are literally paying more in token terms for the wrong answer that then requires the most review time to untangle. What this means practically is that the use cases where the verification tax hits hardest are exactly the use cases that organizations tend to deploy AI first, because they seem high value: legal, compliance, tax, client-facing deliverables, regulated communications. These are the domains where professional judgment carries the most weight, where the cost of error is highest, and where the reviewer's time is most expensive. They're also the domains where AI's hallucination rate tends to be most consequential, because mistakes in these areas don't just require correction, they require documentation that the correction happened. The honest framing is this: in high-stakes professional workflows, AI often shifts work rather than eliminates it. Time savings happen at the generation stage. They get partially or fully recaptured at the verification stage. The net benefit is real but smaller than headline productivity numbers suggest, and it has a hard ceiling determined by how much of the task requires judgment that only a qualified human can apply. This isn't an argument against using AI in professional workflows. It's an argument for being precise about which workflows, which models, which risk thresholds, and what verification process accompanies the deployment. The verification tax is worst where it was designed into the use case from the start and invisible until someone looks at the billing. Zombie seats and the adoption gap. The verification tax is worst in the wrong use cases, which raises the question: where is Copilot actually being deployed? 70% of Fortune 500 companies have officially adopted M365 Copilot. That number gets cited constantly in Microsoft earnings calls and analyst briefings as evidence of enterprise AI momentum. What it actually describes is pilots, limited rollouts, and licensing purchases that preceded any serious change management work. Adoption in the reporting sense means seats were bought. It doesn't mean those seats are producing anything. The conversion rate tells the real story. Across organizations with licensed M365 Copilot access, only about 35.8% of employees actively use it. Roughly 1 in 3 people with a paid license opens Copilot with any meaningful frequency. The other 2/3 have a license assigned, a $30 monthly charge appearing on the invoice, and an interaction history that might show 2 sessions in the last month. One to summarize an email, one out of curiosity after someone mentioned it in a meeting. Compare that to ChatGPT's voluntary conversion rate. Approximately 83.1% of users who have access to it actually use it regularly. That gap isn't explained by capability differences. Copilot has access to organizational data, deep office integration, and the same underlying model infrastructure. The gap is explained by fit. ChatGPT meets users where they already are, in a frictionless consumer interface, doing tasks they chose for themselves. Copilot arrives inside a workplace context where nobody redesigned the workflow around it, nobody trained people on when to use it, and the default answer to "should I use Copilot for this?" is still "I'm not sure." This is the zombie seat, a paid $30 per month license assigned to a user who has it, knows it's there, and generates near zero measurable value from it. Not because they're resistant to AI, because nobody connected the license to a specific task, a specific process, a specific outcome that made using it the obvious choice. The scale of this problem is concrete. At 5,000 licensed users with 35% active usage, you have roughly 3,150 people in the zombie category. That's $97,500 per month, $1.17 million per year, in license spend that is producing nothing you can point to. And that figure only counts the Copilot add-on. It doesn't include the E3 or E5 base licenses those users are also sitting on, or the opportunity cost of having purchased AI access that isn't functioning as an asset. Organizations that have run formal license optimization cycles consistently find 10 to 20% of their total M365 costs are recoverable through identifying and reclaiming idle or redundant assignments. That initial pass usually surfaces the clearest waste: departed employees who still hold licenses, users whose role changed and no longer justifies their current SKU, add-ons assigned broadly for a project that concluded months ago. Organizations that move from periodic audits to continuous automated governance push that figure toward 20 to 30% over time. For a 5,000-seat environment with a fully loaded M365 stack averaging $65 per user per month, 20% waste recovery represents $780,000 per year. That's not cost-cutting, that's a reallocation opportunity. Recovered budget that can fund the Copilot expansion for roles where it actually generates return, or the Copilot Studio agent development for the 2 or 3 workflows where AI delivers a genuinely measurable difference. This is the self-funding narrative that the most disciplined IT organizations are running in 2026. Don't ask the board for more AI budget. Audit the AI budget you already have, recover the waste, and redirect it toward the 35% of users who will actually use what you give them. The money is already in the system. It's just sitting in the wrong seats. Zombie seats are a symptom. The root cause is a deployment model that prioritized speed over fit. The blanket rollout problem. The zombie seat problem didn't happen by accident. It was the predictable outcome of a specific procurement decision that most organizations made in 2023 and 2024, and many are still making today. Call it the license-first approach. Buy the seats quickly, run a light training session, send an announcement email, and let adoption happen organically. The reasoning felt sound at the time. Broad access creates broad familiarity. Familiarity creates usage. Usage creates value. Get the licenses in place and the behavior will follow. The data doesn't support it. The license-first approach consistently produces ROI below 100%, with payback timelines that stretch past any reasonable planning horizon, and license utilization rates that mirror what we just described. Broad access didn't drive broad adoption. It drove broad license assignment, which is a different thing entirely. The failure isn't mysterious once you look at it structurally. Buying a license doesn't change a workflow. It doesn't redesign the process around the tool, identify the specific tasks where AI fits, build the muscle memory for using it, or create accountability for whether it's being used effectively. A license is access. Access without a reason to use it produces the conversion rate we're looking at. 1 in 3 people actually engaging with a tool that costs the same whether it's touched or not. There's a second consequence of blanket rollout that gets less attention than the adoption gap, but it's equally damaging. Governance collapses. When every employee in the organization has access to an AI that can query organizational data across SharePoint, Teams, and email, and nobody has defined what that AI should and shouldn't touch, what gets logged, what gets reviewed, what constitutes appropriate use, you haven't deployed AI responsibly. You've deployed AI chaotically and called it democratization. ROI data from 2026 deployments is consistent on the relationship between usage depth and return. Organizations where 70% or more of licensed users invoke Copilot daily in at least one core workflow see 3 to 4 times the ROI of organizations stuck at 30% weekly active usage. The license cost is identical, the outcome is not. What separates them isn't the quality of the AI. It's whether the deployment was built around a workflow transformation or just a software rollout. The correct model isn't complicated, but it runs against how most procurement cycles operate. You start with a concentrated pilot, a defined set of high-value roles, specific workflows with measurable before and after metrics, dedicated training, and an 8 to 12-week window to generate real data. Not a survey asking people how they feel about Copilot. Actual telemetry, actual cycle times, actual throughput numbers. Then you expand only where the data supports it, role by role, process by process, with governance controls in place before the next wave of licenses ships, not after. Most procurement cycles work on annual commitment timelines with volume-based pricing pressure at renewal. The incentive structure pushes toward buying more seats than you can absorb, because the price per seat improves with volume and the EA negotiation is a once-a-year window. This means organizations often acquire 2 or 3 years' worth of AI licensing in a single transaction before the deployment maturity exists to justify it. That's how the zombie seat population scales so fast. And it's why the fix isn't a technology problem, it's a deployment model problem. To build the right model, though, you need to understand what Copilot is actually competing against when you're deciding where to spend that recovered seat budget. What traditional automation actually costs. Before you can make a rational decision about where AI spend belongs in your automation portfolio, you need an honest baseline for what the alternatives actually cost, not the marketing version, the unit economics version. Robotic process automation has been the enterprise automation workhorse for the better part of a decade. The cost structure is straightforward. Unattended bot licenses typically run $8,000 to $20,000 per year depending on vendor, edition, and contract size. Add infrastructure, virtual machines, orchestrators, monitoring tools, and implementation costs, which can match or exceed the first year of licensing on complex deployments. Then factor in ongoing maintenance because RPA bots are brittle. When the UI changes, when the upstream system gets updated, when the form layout shifts, someone has to go fix the bot. That maintenance cost is real and recurring. But here's what makes RPA compelling for the right use cases. Once a bot is deployed against a stable, high-volume process, the marginal cost per execution approaches 0. An unattended bot running invoice posting 100,000 times a year against a system that doesn't change, against a data format that stays consistent, that bot's effective cost per task can fall to $0,001 to $0,05, depending on how you amortize the build and maintenance overhead across volume. At scale, with process stability, RPA's cost per transaction is nearly free. Deterministic scripts are even cheaper. A Python microservice that validates data against a business rule, transforms a file format, or routes a record based on a field value runs on commodity compute. The per call cost is in the range of fractions of a millionth of a dollar. Not fractions of a cent, fractions of a millionth of a dollar. For mechanical, well-specified logic with no ambiguity, this is the floor. And it's a very low floor. Now, 2026 changed part of this equation. LLM API costs dropped roughly 80% between early 2025 and early 2026, driven by model efficiency improvements, hardware scale-out, and intense competition across providers. That price collapse made AI agents genuinely competitive for unstructured work. the tasks that were never viable for RPA in the first place. Email classification, contract extraction, document summarization, ambiguous routing decisions. These are tasks where RPA has always struggled because the inputs don't conform to a predictable structure. For those tasks, an AI call at fractions of a cent is now often cheaper than building and maintaining the rules-based alternative. But for structured work, the comparison is still brutal. An AI model doesn't get cheaper with volume the way an RPA bot does. Every prompt costs tokens, every output costs tokens. Scale from 10,000 invoice validations to 100,000 invoice validations, and your AI cost scales linearly. The RPA cost barely moves once the bot is running. For deterministic, high-volume, stable processes, AI's variable cost structure is a fundamental disadvantage that no model price reduction has yet overcome. This is where the strategic question sharpens. Organizations evaluating AI or RPA are asking the wrong question. The right question is, which layer of this workflow requires judgment and which requires execution? Judgment. Reading intent from an ambiguous email, extracting meaning from an unstructured document, deciding how to handle an exception that doesn't fit a predefined category. That's where LLMs earn their cost. They're flexible, they generalize across input variation, they handle the cases a rules engine would have to explicitly anticipate. For that layer, even today's AI prices are often justified. Execution, updating the CRM record, posting the journal entry, moving the file, triggering the downstream workflow, that's mechanical. It's deterministic. It follows rules. RPA handles it at near zero marginal cost once it's deployed, and a deterministic script handles it cheaper still. There is no judgment involved, which means there's no reason to pay judgment prices for it. Using a reasoning engine to perform a mechanical task is the most expensive mistake in modern enterprise automation. Not because the AI is bad at the task, it can do it, but it costs 500 times more than the alternative. For identical output quality, that cost gap becomes catastrophic when you move from individual tasks to automated workflows, and that's exactly where most organizations are pushing Copilot right now. The agentic cost explosion, the unit economics shift dramatically when you move from Copilot's chat interface to agentic workflows, tasks where the AI doesn't just generate a response, but plans multiple steps, calls tools, evaluates outcomes, and iterates toward a solution. A standard conversational interaction with Copilot consumes roughly 2,000 tokens. You ask a question, you get an answer, the conversation ends. A single agentic task, where the system researches a topic across multiple sources, drafts a comprehensive response, validates the output against requirements, identifies gaps, and refines the draft, consumes between 200,000 and 1,000 tokens. That's not a 10x difference. That's up to a 500x multiplier on token consumption for what appears to be a single user request. This massive escalation was quantified in a 2025 Stanford Digital Economy Lab study in partnership with Microsoft Research. The finding was stark. Agentic workflows consume orders of magnitude more tokens than interactive chat because every planning cycle, every tool invocation, every evaluation loop represents a full inference pass through the model. A 3-step plan becomes 3 separate token events. A 5-turn refinement cycle becomes 5 more. What users perceive as one task generates dozens of internal computations, each one built independently. The cost math is unforgiving. At Claude Sonnet 4.6 pricing, 3 per million input tokens, 15 per million output tokens, a mid-range agentic task consuming 300,000 tokens costs approximately $1.50. A complex agentic task at 1 million tokens reaches $5.40. These numbers are single instances. Scale them across a team, across a day, across a quarter, and they accumulate into material line items on your Azure bill. But here's where it gets genuinely uncomfortable. NVIDIA executives have publicly stated that AI token-based pricing for enterprise automation is in some cases already exceeding the annualized cost of employee salaries for comparable workloads. Let that sink in. A single sophisticated agentic workflow running daily, consuming 1 million tokens at frontier model prices, can cost more per year than paying someone a salary to do the work manually, without guardrails, without limits, without cost awareness built into how the system decides which workflows get to run at which model tiers. The cost explosion problem isn't unique to any single vendor or model, it's structural. Agentic systems work by decomposing complex goals into subtasks, then executing those subtasks with AI assistance. Every subtask is a prompt response cycle. Every prompt carries context. Every response generates output. The system's intelligence, its ability to break down problems and iterate towards solutions, is the same property that makes it expensive at scale. Organizations deploying agentic workflows in 2026 are discovering this in real time. A knowledge management agent that crawls your document repository to answer questions can generate hundreds of thousands of tokens per user per week if nobody constrained its search scope. A customer service agent that routes inquiries to appropriate teams can spawn multiple parallel workflows investigating the same issue if nobody built in deduplication logic. A compliance agent that generates regulatory summaries across multiple jurisdictions can run unbounded searches across your entire legal repository unless someone explicitly capped the query depth. These aren't failures of model capability, they're failures of governance. An agentic system without spending controls is an agentic system that will eventually generate a bill nobody expected. The classic incident, now becoming common enough to have patterns, involves sub-agent fan-out. One agent spawns multiple child agents to parallelize work. Each child agent independently generates tokens consuming compute, and without a circuit breaker, the system scales to absurd costs. GitHub users in early 2026 experienced incidents where a single agentic workflow spike generated $47,000 in compute charges in the course of an afternoon, with no human intervention or oversight. The agent worked exactly as designed, it just wasn't designed with cost as a constraint. Token costs must be managed like labor costs, with budgets, with utilization targets, with clear cost per business outcome metrics that force explicit trade-offs. Run this agent on the expensive reasoning model or run it on the cheaper general model. Route this workflow through a local model or call the Frontier API. These aren't technical questions, they're business questions, and they require the same governance apparatus you'd build for any significant operational cost. The enterprise without token governance infrastructure in place is the enterprise that discovers a $47,000 incident on its Azure bill and realizes nobody owns the decision about which agents can run, at what cost, for what benefit. Now we have the full picture of what's bleeding cash. The question is where the money is actually well spent. Where Copilot actually wins. The argument so far has been relentlessly negative, and for good reason. The structural flaws are real, the waste is quantifiable, the governance gaps are consequential. But Copilot ROI is not a myth. It's real, it's just highly concentrated, and most organizations are deploying it in a way that diffuses the return across too many seats to make it visible. The break-even threshold is simple to calculate. At a fully loaded labor cost of $50 per hour, a $30 per month license becomes economically rational if the user captures just 36 minutes of save time per week. 36 minutes, not even an hour. For that 36-minute threshold, an organization has already crossed into positive ROI territory. The CFO doesn't need to believe in productivity magic. Just 36 minutes of actual time recapture per week per user. Real-world data from organizations that deployed Copilot with intentional adoption programming, not just seat assignment, but structured training, champion networks, role-specific prompting libraries, and measurable success metrics, shows that users consistently reach 3 to 4 hours per week saved at maturity. A Forrester Total Economic Impact study commissioned by Microsoft, working with client data from organizations that actively drove adoption and process redesign around Copilot, reported 116% ROI in the first year alone. That's a floor, not a ceiling. But here's the critical constraint. ROI concentrates in specific work patterns. Not all roles, not all tasks. Specific roles, specific workflows where Copilot's strengths align with actual bottlenecks in how work gets done. The high-value profile is straightforward. Document-heavy roles, communication-heavy roles, analysis-heavy roles, knowledge workers who spend hours each week in Outlook, Teams, Word, Excel, and PowerPoint. People who draft, revise, summarize, search, analyze, and synthesize as the core of their job, not as a marginal activity. The strongest use cases are concrete. Drafting proposals and RFP responses, Copilot can scaffold the structure, pull relevant prior language, and generate first-pass content that a senior consultant refines into the final bid. Summarizing meeting transcripts and long documents, Copilot can extract decisions, action items, and key points from hours of recorded content in seconds. Cross-system search across email, Teams, and SharePoint, retrieving relevant context from organizational memory without manual navigation. First-pass Excel analysis, generating formulas, suggesting pivot structures, identifying outliers before a financial analyst fine-tunes the model. These aren't speculative use cases. Sales organizations, consulting firms, legal departments, and product management teams have reported consistent 3 to 4 hours per week saved at deployment maturity. At a $75,000 fully loaded annual salary, that's $5,625 in annual time value per user. The license costs $360. The math is not close. The ROI multiplier that distinguishes thriving Copilot deployments from failing ones is adoption depth. Organizations where 70% or more of licensed users invoke Copilot daily in at least one core workflow see 200 to 400% first-year ROI. Organizations stuck at 30% weekly active usage see near zero return. Same license cost, same model, same potential, 3 to 4 times the actual outcome, driven entirely by whether the organization engineered usage into the workflow or just assigned seats and hoped. This is where the tiered access framework becomes not a cost-cutting exercise, but a concentration strategy. You're not trying to minimize Copilot spend, you're trying to maximize Copilot ROI per dollar spent, which means concentrating licenses where the work pattern matches Copilot's strengths, where process redesign is feasible, and where the labor cost saved justifies the infrastructure cost, and letting everyone else access the free or bundled tier for the cases where Copilot is a utility, not a critical capability. The organizations seeing the best outcomes are not the ones that bought the most seats. They're the ones that bought the right seats in the right roles, backed by structured enablement, governed by clear metrics, and resourced with change management. That's how you move from a deployment that bleeds cash to a deployment that generates return. Knowing where it wins tells you how to build the framework that captures that value instead of diffusing it across the organization like expensive overhead. The tiered access model. The structural answer to both the zombie seat problem and the agentic cost explosion isn't to deploy more broadly or more conservatively. It's to deploy differently, with explicit tiers that separate who gets what capability, under what conditions, and with what governance attached. This isn't a new concept. Financial institutions have used tiered access for years. Basic customer service reps get read-only access to accounts. Supervisors get limited modification rights. Senior staff get unrestricted system access with logging. You're applying the same principle to AI, but organized around value and risk rather than organizational hierarchy. The framework typically works like this. Tier 3 is broad access with minimal controls. Think of this as the free Copilot tier available to all staff. These users get access to public or well-curated internal knowledge bases, but not direct access to sensitive corporate data. They can use Copilot for writing, translation, summarization of non-sensitive material, generic Q&A. No agent creation, no custom integrations, no ability to connect to line of business systems. The model is constrained to prevent leakage of confidential information, and the usage footprint is monitored but not heavily governed. This tier is cheap, either completely free or bundled into existing licenses. And the expectation is that a large portion of the organization lands here. Tier 2 is for standard knowledge workers whose role directly benefits from deeper AI capability. They get full M365 Copilot licensing with access to departmental content, their email, their Teams channels, their shared SharePoint sites. They can ask Copilot questions about organizational policies, internal processes, customer accounts within their department, standard app integrations with Word, Excel, PowerPoint, Outlook, and Teams. They can run basic automations and workflows, but cannot create custom agents or modify governance policies. The cost is the $30 per month add-on, but it's concentrated on roles where documented usage patterns show concrete ROI. Sales teams, legal departments, financial analysts, project managers. Governance is active. There are clear policies about what Copilot can and cannot access, with periodic reviews of usage patterns. Tier 1 is restricted access for high-value, high-risk work. This is where custom agents live. This is where board-level or senior executive decisions get AI-assisted. This is where sensitive data like M&A planning, proprietary research, or regulated compliance work flows through Copilot. Access is explicitly provisioned. You don't get Tier 1 access because of your job title. You get it because a specific high-value workflow requires it, and the governance overhead is worth the business case. These agents run under strict conditional access policies. They have restricted SharePoint search scope. They log everything. Changes to their prompts or tool integrations go through formal change management. The compliance and legal review is heavyweight. The cost per agent is higher, not because the license is more expensive, but because the governance infrastructure around it is more expensive. The business case for tiering is straightforward. Concentrate the $30 per month add-on spend on the 35% of users who will actually generate 3 to 4 hours per week of time value. Let the other 65% use free or bundled Copilot for the cases where they benefit incidentally. The reallocation isn't a cost-cutting exercise. It's a return optimization exercise. You're moving budget from low utilization seats to high impact workflows. You're recovering the zombie seat spend and redirecting it toward agents and capabilities that drive measurable business outcomes. Access tiers must be tied to governance controls, not just job titles. Sales director doesn't automatically equal tier 2. Rather, you ask, does this role spend significant time in document-heavy workflows where AI can materially reduce cycle time? Does the team have process discipline around how AI outputs get used? Are there clear success metrics? If yes to all three, provision tier 2. If not, tier 3 with a clear path to upgrade once conditions are met. This is a portfolio management decision, not an IT configuration decision. You're not optimizing for how many people can we give AI to. You're optimizing for how do we maximize business value per dollar of AI spend while keeping governance risk under control. The tiering framework is what enables that optimization to actually function as a lived practice instead of a theoretical ideal. Token governance as a financial discipline. Once you've built the tiered access framework, you've solved the structural problem of who gets what capability, but you haven't solved the operational problem of managing how much that capability costs once it's in use. That requires a different kind of discipline entirely. Think of token governance as FinOps applied to AI. Cloud cost management emerged as a discipline because cloud infrastructure is metered. You get a bill for every compute hour, every gigabyte stored, every terabyte transferred. Organizations that didn't actively manage cloud spend watched their bills grow 30 to 40% year over year. even when actual workload demand stayed flat. The solution wasn't to use less cloud, it was to build operational practices that made cloud cost visible, attributable, and subject to budget discipline. Token governance applies the same principle to LLM consumption. The first operational step is to segment your user base into consumption profiles. Not everyone is a heavy user. Light users, those using Copilot occasionally, mostly for straightforward tasks like email summarization or quick document search, consume between 40,000 and 100,000 tokens per month. Heavy analytical users, consultants building research-backed deliverables, engineers debugging complex systems with extended context, analysts processing document sets, can reach 1.6 million tokens per month. That's a 16 to 40-fold difference in consumption from the same license type. Understanding where your population actually falls on that curve is the foundation for meaningful governance. But consumption tracking alone is sterile if you're just counting tokens. What matters is cost per business outcome. Don't track cost per token. Track cost per merged pull request, cost per proposal drafted, cost per support case resolved. That reorientation accomplishes two things. First, it ties spending to actual value, making it clear when token consumption is growing faster than the outcomes it's producing. Second, it creates a natural conversation about whether the outcome justifies the spend, which is the core question any business discipline should answer. Prompt governance is the most immediately actionable lever. Large persistent instruction blocks, shared system prompts, global configuration files, detailed context about your organization's policies and processes get injected into every single interaction. If that shared context is 2,000 tokens and it lives in every prompt, then every Copilot user is paying a 2,000 token tax on all interactions, whether that context is relevant to the specific query or not. Trim that shared instruction set to essentials. Segment context by role or department so users only carry the instructions relevant to their work. The Claude Code case studies document 40% cost reductions from simply moving large persistent context files out of active prompts and into documentation or knowledge bases that get consulted when needed rather than injected always. Session lifecycle control compounds this. An IDE session left open overnight, where a developer had a rich conversation about a code base earlier in the day, carries the full conversation history into every subsequent interaction the next morning. When that developer switches to a completely different code base, that old context is still being carried forward, still being charged as input tokens on every new request. Encourage users to reset or clear sessions when switching tasks. Make session reset a deliberate action in workflow guidance. The cognitive load on the model and the token bill drops as soon as that irrelevant context is dropped. Model routing is where disciplined token governance becomes cost reduction theater. Not every task requires a frontier model. A routine code completion can run on a smaller, faster, cheaper model. Complex multi-step reasoning should escalate to a more capable tier. If 70% of your interactions are straightforward and 30% are complex, route the straightforward work to a cheaper tier automatically. The documented case studies show this discipline alone. Deliberate model selection based on task complexity, rather than defaulting everything to your most capable model, produces between 70 and 85% reductions in total token spend while maintaining quality on the tasks that require it. Finally, set spend limits and alerts. Treat token budgets the way you'd treat headcount budgets. Department gets allocated X tokens per month. Once they approach the limit, they get visibility and a conversation with finance. Individual workflows get spending thresholds. Agentic systems get circuit breakers that prevent runaway token consumption. Without explicit limits, cost grows invisibly until an invoice arrives that nobody expected. Governance without measurement is policy theater. Governance with measurement is operational reality. The ROI audit framework. Measurement and governance work backward from a simple fact. Most organizations deployed Copilot without capturing what before looked like. You can't calculate ROI if you never measured the baseline. You can't prove the time was saved if you didn't document how long the task took before AI arrived. This baseline problem compounds across every other dimension of an audit framework. A real Copilot ROI audit operates across 8 interconnected dimensions. Each one answers a specific question that feeds into the others. Dimension 1 is strategic alignment. Does every licensed user have a documented relevant use case? Not, maybe they'll use this eventually. Documented. A concrete answer to where does this person use Copilot? If you can't articulate that, the license is speculative spend, not strategic investment. What percentage of your licenses align to high-impact processes where documented ROI patterns exist? Sales, legal, consulting, financial analysis, versus roles where Copilot adoption is still experimental? Dimension 2 is baseline and benefit measurement. This is where the actual time data lives. How long did a specific task take before Copilot? How long after? Take the time saved, multiply by fully loaded labor cost, multiply by adoption rate. That's your monetized benefit. Compare it to license cost plus enablement overhead. This is the one dimension you cannot eyeball or guess at. The CFO will not accept survey responses about how Copilot feels faster. They will accept before and after cycle times against defined tasks. Dimension 3 is adoption behavior. What fraction of licensed users invoke Copilot daily in at least one core workflow? Weekly, monthly, this is where usage telemetry becomes ground truth. The admin center usage reports show this. The graph APIs expose it. You need to know the conversion rate, the real number, not the aspirational one. Organizations with 70% or higher daily active usage see fundamentally different ROI profiles than organizations at 30%. The metric is not controversial. What organizations do with the metric is where the real discipline lives. Dimension 4 is technical readiness and performance. Are all users on supported M365 update channels? Do they have the right base licenses? Is there latency or reliability friction that suppresses adoption? Technical friction doesn't feel like a cost until you realize it's preventing the time savings you're supposed to be capturing. Dimension 5 is data governance quality. Can Copilot deliver useful answers if your SharePoint is a maze of overshared folders and unlabeled documents? A cleaner data estate increases ROI by improving answer quality while simultaneously reducing compliance risk. This isn't theoretical. Organizations that skip this step discover it through a security incident, not a success metric. Dimension 6 is cost and licensing optimization. Identify which licenses are actually generating value and which are occupying seats. Find users whose role changed and no longer justifies their current SKU. Reclaim licenses from consistently low usage accounts. Reallocate to high-value roles. This is not cost-cutting. This is capital redeployment from low-return to high-return users. Dimension 7 is change management and enablement. Did you run formal training beyond an email announcement? Do you have champions in each department who can model usage and troubleshoot? Is there an ongoing enablement program or just an initial onboarding? Change management has a direct correlation with adoption depth, and adoption depth drives ROI by 3 to 4 times. Dimension 8 is continuous improvement and governance. How often are you reviewing ROI metrics? Are you adjusting which tiers users belong to based on actual usage patterns? Have you built feedback loops where usage data informs policy and policy informs usage allocation? The quarterly license audit is not optional. It's the mechanism that converts recovered spend into funded expansion. Without it, waste accumulates invisibly, and the next budget cycle perpetuates the same inefficiency. The audit tells you what's broken. The next step is fixing the deployment model. The self-funding AI strategy. The audit identifies the waste. The tiered framework concentrates where you actually want to spend. But where does the budget come from to fund the expansion? This is where the self-funding narrative shifts from cost consciousness to capital strategy. The mechanism is straightforward. Independent advisors and SAM specialists consistently report that organizations uncover between 10 and 20% in unnecessary license costs during their first formal optimization cycle, not through aggressive cuts, through reclaiming seats that are actively assigned but generating zero measurable value. Users who left the organization but still hold licenses. Roles that changed and no longer justify E5 level access. Add-ons purchased for short-term projects that concluded months ago. Continuous automated governance, where systems continuously audit usage and reallocate based on behavior rather than waiting for annual cycles, pushes that recovery range to 20 to 30% over time. For a 5,000 user organization where 30% of seats are genuinely idle at the current per seat cost of $30 per month, that idle population is carrying $540,000 per year in unproductive Copilot spend alone. Add the base E3 or E5 licenses those users are also holding, and the total recoverable cost climbs significantly higher. That's not a marginal adjustment. That's substantial capital sitting in the wrong allocation. The self-funding narrative works because that recovered budget doesn't disappear. It funds exactly the capabilities that generate return. Targeted Copilot expansion to the high ROI roles you identified in your strategic alignment audit, the sales teams and consulting practices where documented usage patterns show 3 to 4 hours per week saved. Copilot Studio agent development for the 2 or 3 specific workflows where you measured concrete business outcomes. The compliance research agent, the CRM routing agent, the proposal scaffold agent. Azure OpenAI capacity for custom applications where token economics favor direct billing over per user licenses. The specialized domain Copilot that needs fine-tuning. The vertical specific agent built on proprietary data. The reallocation works at scale because concentration beats coverage in terms of ROI. We've already established that organizations hitting 70% or higher weekly active usage see 3 to 4 times the return on the same Copilot license compared to those stuck at 30%. That's not because the model improved, that's because the deployment changed. The same $30 monthly investment produces a 4-to-1 difference in outcome based on whether you're spreading it thin across a population or concentrating it in roles where the work pattern makes AI genuinely useful. The phased expansion model operationalizes this principle. You don't recover zombie seat licenses and immediately redeploy them to the next 1,000 people. You pilot with a concentrated group, 100 to 500 users in genuinely high-value roles. You measure rigorously. Time data, adoption metrics, cost per outcome. Only when the data supports it do you expand to the next cohort. Then repeat. Each phase is a funding gate. You don't get more budget unless the prior phase demonstrated return. This approach inverts the risk profile of AI spending. The blanket rollout model, buy many seats, hope adoption follows, puts all the risk up front. You've committed the budget and the infrastructure before you know if it will generate return. The self-funding model defers the risk. You prove return with a constrained group. You recover waste from the broader organization. You reinvest that recovered capital into expansion, but only in the directions where data already validates the outcome. This is not a cost-cutting exercise disguised as strategy. It's the opposite. You're preserving or expanding your AI capability footprint while dramatically improving the efficiency of every dollar deployed. The total AI budget doesn't necessarily shrink. The return per dollar dramatically improves. And the funding mechanism, reallocation from low return to high return uses, is internally sustainable, which means you're not asking the board for more budget to fund better AI strategy. You're funding it by not wasting what you already have. Before you can execute this reallocation effectively, though, you need to address one structural prerequisite that most organizations haven't actually solved: the data governance prerequisite. Before you can execute any of this, the tiered framework, the token governance, the ROI audit, there's a foundational layer that almost every organization underestimates: data quality and access control. Copilot's value is tightly coupled to how clean your data estate actually is, not theoretically, operationally. When you grant Copilot access to your SharePoint, Teams, and email archive, you're not just enabling productivity, you're exposing every permission misconfiguration, every document that shouldn't be broadly accessible, every folder structure that nobody's touched in 3 years because nobody remembers why it was created. Copilot doesn't create data access problems. It surfaces existing ones at unprecedented speed and scale. A human searching SharePoint manually might dig through 5 or 6 documents before giving up. Copilot can ingest 50 documents in the time it takes a human to open the search interface. If half those documents were never intended to be accessed by the person running the query, if they contain M&A preparation, unreleased product roadmaps, or confidential client information, Copilot surfaces all of it with zero friction. The access control failed long before Copilot arrived. Copilot just made the failure visible. The pre-deployment requirements are concrete. Run a permissions audit across SharePoint, OneDrive, and Teams. Find folders shared with anyone with the link. Find Teams channels where guest access is active for people long since departed from the organization. Identify documents marked sensitive but shared broadly anyway. Remediate the oversharing. Implement sensitivity labels that actually cover active content and not the aspirational labels you defined 2 years ago, but the labels that reflect how your organization actually classifies information today. Set up restricted search parameters so Copilot doesn't return results from data the requesting user doesn't have legitimate access to. This work is not glamorous. It doesn't show up in a productivity demo. It's also not optional if you want Copilot to function as a capability rather than a liability. Here's the practical consequence. Organizations that skip the data governance prerequisite and deploy Copilot into a dirty data environment experience 2 simultaneous problems. First, Copilot's quality degrades because it's pulling from a messy knowledge base full of outdated, redundant, and conflicting information. Users ask questions and get answers that are technically accurate but strategically obsolete or contradictory depending on which document Copilot happened to rank higher. Second, compliance and security exposures spike because Copilot is surfacing sensitive information that should never have been broadly accessible in the first place. The security incident is how most organizations discover they skipped this step, not through an architecture review, through a breach or an audit finding. Someone accesses information through Copilot that they shouldn't have had permission to see, and suddenly governance becomes urgent in a very different way. A cleaner data estate increases ROI by improving answer quality while simultaneously reducing compliance risk. It's not a trade-off where you improve one at the expense of the other. They move together. Better classification and access control means Copilot returns more relevant, more recent, more trustworthy information. Better access control means Copilot's search scope is constrained by legitimate permission boundaries rather than exploding across everything the organization ever documented. Data readiness is not an IT prerequisite, it's a business prerequisite. Your CFO needs to understand that before Copilot can work, your SharePoint environment needs to function like an actual information architecture rather than a filing cabinet where everything eventually gets dumped. Your legal team needs to confirm that the content Copilot will have access to is classified appropriately. Your business leaders need to own the decision about what data Copilot can surface to whom. That's the foundation before anything else in the framework actually lands cleanly. The hybrid automation architecture. The architecture question is no longer binary. You're not choosing between deploy Copilot everywhere and stick with RPA. The organizations seeing the best outcomes in 2026 are building something different entirely. A layered stack where each component handles the work it's cheapest and most effective at performing. Think of it as 4 distinct layers, each with its own cost profile and responsibility. The interpretation layer sits at the top. This is where language understanding lives. You have incoming email with unstructured text, or a document in PDF format with inconsistent layouts, or a customer support chat thread mixing technical details with emotional context. These inputs don't fit predefined templates. They require judgment. They require someone or something to read intent and extract meaning. This is where LLMs operate. Classification. Is this email a complaint, or a question, or a request for information? Extraction. What are the key entities and what does the customer actually need? Summarization. What's the one-paragraph version of this 50-page contract? The interpretation layer is pure AI work. The cost scales with token consumption, but the value it produces, converting messy, unstructured input into clean, structured signal, is what makes the entire downstream workflow possible. The execution layer does the mechanical work. Once you've extracted meaning from that email, someone needs to update the CRM record, create a ticket in the help desk system, move a file from inbox to archive folder, post a transaction to the general ledger, log an action in the project management system. These are deterministic, rules-based, predictable operations. They don't require judgment. They require precision and consistency. This is where RPA or deterministic scripts operate. The cost here approaches zero once deployed because you're not reasoning about anything. You're just moving data and triggering workflows. The marginal cost per execution is fractions of a cent, or in the case of a Python script, fractions of a millionth of a dollar. The supervisory layer handles what neither AI nor RPA can safely own: exceptions, approvals, high-stakes decisions. The email that came in wasn't a standard request. It's a special circumstance requiring human judgment. The transaction looks like a duplicate but might not be. The contract contains a clause that deviates from standard language and needs a lawyer's opinion before it's committed. Humans handle these cases. The cost is whatever the fully loaded labor rate is for the person doing the review. It's expensive compared to AI or RPA, but it's necessary because the reputational cost and legal liability of getting these cases wrong far exceeds the labor cost of handling them thoughtfully. The control layer is the infrastructure that makes the whole stack defensible. Governance, audit trails, compliance logging, observability into what's happening at every stage. Which AI model ran? What were the input tokens and output tokens? Which RPA bot executed? Did a human approve this transaction before it was posted? What happened when the system encountered an exception? This layer doesn't execute work. It certifies that work happened correctly, that decisions are traceable, that mistakes can be identified and corrected. It's not cheap, but it's how you prove to regulators, auditors, and your own executive team that automation is happening under control. The practical mechanics are worth walking through. An email arrives, the interpretation layer, an LLM running a classifier task, reads it, determines intent, and extracts structured data. Cost, fractions of a cent. Output, a decision about what to do next, and the key information needed to do it. The execution layer, RPA, or a deterministic script, takes that structured data and executes the workflow. It updates the CRM, logs the action, routes the case to the appropriate queue or person. Cost, near zero marginal expense. The supervisory layer reviews exceptions, the 5 or 10% of cases where the interpretation wasn't confident or the situation requires judgment. A human person makes the final call. The control layer logs everything, creates an audit trail, flags anomalies. The cost advantage of this hybrid model is compound. You pay AI prices, which are variable and token dependent, only for the interpretation work, where human labor would be even more expensive. You pay near zero execution prices for the deterministic work, where RPA or scripts are vastly cheaper than asking an AI to do mechanical tasks. You pay human labor rates, which are expensive, but only for the exceptions and decisions that actually require human judgment. You're not forcing expensive reasoning engines to do mechanical work, and you're not using cheap deterministic scripts for tasks that require contextual understanding. The result is an automation stack, where cost aligns to value and risk aligns to control. Not hype, not hope. Structural economics. Building your Copilot business case. A defensible business case in 2026 looks materially different from the AI business cases of 2024 and 2025. The difference isn't academic. It's the difference between getting budget approved and getting budget revoked after the first renewal. The 5 components that make a case defensible are baseline metrics, conservative time savings assumptions, pilot design, measurement methodology, and scale criteria. You need all 5, and they need to work together as an integrated model, not as separate justifications that you stack together and hope nobody asks hard questions about. Baseline metrics means you've captured how long specific tasks take before Copilot arrives, not estimates, actual data. If proposal drafting is your target use case, you've timed how long a senior consultant spends on a typical RFP from intake to delivery. If meeting summarization is the focus, you've measured how long it takes someone to review a recorded meeting and produce actionable notes. If email triage is the driver, you've documented cycle time from message arrival to initial response. This baseline is your control group. Without it, you can't measure the delta. Without the delta, you can't calculate ROI. The CFO will accept nothing less than documented time data. Conservative modeling is where you protect yourself against the optimism trap. The Forrester study reported 3 to 4 hours per week saved at maturity. That's the upper bound. Your business case should assume 30 to 60 minutes per week saved as your primary model. Run sensitivity analysis up to 3 to 5 hours per week for mature users, but lead with conservative assumptions. If your case only works if you hit the optimistic scenario, you've built a case that will fail the moment adoption underperforms or task complexity turns out to be higher than expected. Build the case so it works at conservative assumptions and outperforms from there. Pilot design is the operational linchpin. You're not deploying Copilot to the entire organization and measuring what happens. You're running a controlled experiment with 100 to 500 users in specific roles for 8 to 12 weeks. The roles are chosen explicitly: sales, legal, consulting, product management, customer service, because they're document-heavy and communication-heavy, and you've already hypothesized that Copilot fits their workflow. The users in those roles get dedicated training, not a generic email announcement. You create role-specific prompting libraries so people aren't starting from scratch. You establish clear success metrics per process, not "did people like it?" Metrics like "did proposal cycle time drop 20%?" Or "did email response time improve 15 minutes per interaction?" Or "did document revision cycles shrink from 3 rounds to 2?" Measurement methodology is the operational discipline that captures those metrics rigorously. You're tracking cycle time, throughput, error rates, and adoption depth. Adoption depth means daily active usage in core workflows, not license assignment. You're capturing this data before the pilot starts, continuously during the pilot, and at a defined endpoint so you can quantify the before and after gap. You're not conducting surveys asking people how productive they feel. The CFO will dismiss productivity feelings as anecdote. You're showing measurable change in how work actually flows. Scale criteria is where you define the graduation gate. You've run your pilot and gathered 12 weeks of data. You've calculated ROI based on measured time savings multiplied by fully loaded labor cost and compared to license costs plus enablement overhead. You've set a threshold, maybe 150% ROI minimum, maybe 6-month payback requirement, maybe 60% adoption depth in the pilot cohort. Whatever your threshold is, it needs to be explicit and documented before the pilot starts. Once the pilot ends, you measure against that threshold. If you hit it, you expand. If you don't, you diagnose why and iterate before committing to a wider rollout. The critical insight that most organizations miss is that ROI tracks adoption, not licenses. You can buy all the seats you want. ROI doesn't follow, adoption follows. Change management and training are not overhead. They are the line items that determine whether the license actually generates return. Include them in your cost model from the beginning, not as an afterthought. A business case built this way is defensible with the CFO because it's built on the same logic finance uses to evaluate any investment: documented baseline, conservative assumptions, measurable outcomes, gated expansion. What the next 12 months require. The structural shifts happening in 2026 aren't temporary, they're directional. Microsoft's consumption-first strategy is accelerating across the entire stack. The hybrid model, mixing per-user licenses with metered capacity consumption, is hardening into the standard rather than the exception. Security Copilot, which launched bundled into M365 E5 with monthly security compute unit allocations, is essentially a technical preview of how all Copilot consumption will eventually flow. You're looking at a future where Copilot licensing works like cloud infrastructure did 5 years ago. Predictable base costs plus variable consumption on top, with no unified dashboard to track it all. Organizations that build token governance infrastructure now, the observability systems, the budget controls, the cost per outcome metrics, will have a structural cost advantage as consumption billing expands. You're not betting on a future model, you're preparing for the one that's already here. The ones still operating on hope and assumption will discover they need governance infrastructure the moment an unexpected invoice arrives and nobody can explain it. 3 immediate actions compress the urgency. First, conduct a full license and usage audit across M365 and any GitHub Copilot deployments. Not aspirational metrics about what you think people use. Actual usage data from the admin center and usage reporting APIs. Identify which licenses are generating measurable value and which are seats in name only. This isn't theoretical, this is capital redeployment preparation. Second, define role-based license templates. Explicit mappings that say sales role gets tier 2 with X capabilities, frontline staff gets tier 3 with Y constraints, engineering leadership gets tier 1 with Z governance. These templates aren't permanent. They're the framework that governs initial provisioning and guides upgrade decisions as actual usage data accumulates. Third, integrate Copilot usage telemetry into your quarterly business reviews. Make token consumption and cost per outcome visible to the business owners who control the budget. Finance sees the line item. Engineering sees the adoption curve. Sales sees time impact on deal cycles. Visibility precedes discipline. The 12-month horizon is the bridge between where you are now and where you need to be. 12 months from today, the conversation shouldn't be, we have Copilot licenses, but we have a governed AI portfolio with measurable ROI per tier, recovering 30% of idle spend, and reinvesting that capital into high-impact agent development. That's not aspirational, that's operational reality for the organizations moving at scale right now. The competitive gap is widening, but not in the direction most people assume. It's not widening between organizations that have AI and those that don't. Everyone has AI now. The gap is widening between organizations that govern it, with explicit tiers, clear metrics, token budgets, and cost per outcome discipline, and organizations that don't. The governed ones see 3 to 4 times the return on the same license spend. They're recapturing 30% of idle investment. They're deploying agents confidently because they understand the cost profile and have the controls in place to prevent surprises. The ungoverned ones are treating Copilot like an infinite utility, wondering why their invoices are climbing and unable to articulate what they're getting in return. The Copilot tax is not inevitable. It's a choice. Organizations that deploy without a framework, that assume broad access, will naturally drive adoption, that don't measure baselines before deployment, that don't tier access by ROI or risk, that lack token governance infrastructure. Those organizations are choosing to bleed cash. The organizations that deploy with the framework we've outlined in this episode are choosing differently. They're extracting return, they're managing risk, they're making capital allocation decisions based on evidence rather than hope. The work starts now, not after you've built the perfect solution. Now, the best time to establish governance was before you deployed Copilot. The second best time is today. The Copilot tax isn't just a line item on your Microsoft invoice, it's the gap between the potential you bought and the value you're actually capturing. It's the 48% verification burden, it's the 60% idle token waste, it's the zombie seats sitting in roles that don't need reasoning engines to do mechanical work. But as we've seen, this isn't an inevitable cost of doing business, it's a governance choice. If you build the tiers, audit the baselines, and treat tokens like a financial discipline, you don't just stop the bleeding, you fund the future. If this episode changed how you think about your AI strategy, or if it gave you the data you need for your next budget review, follow me, Mirko Peters, on LinkedIn. I'm always looking for the next structural flaw to deconstruct, and your feedback helps me find the topics that matter most right now. And if you want more deep dives into the reality of the M365 ecosystem, subscribe to the M365 FM podcast. Leave a review while you're there. It helps more leaders find this framework before their next renewal. Share this with your team, especially if you're looking at your 2026 budget right now.